Hello guys, welcome to the 6th lesson of DBA from Introduction to Practice. I'm your old friend Peng Wang, the global technical evangelist for OceanBase. Today, we will dive into how to use OceanBase Community Edition for business development. Whether you are new to OceanBase or looking to sharpen your skills, you are in the right place. Let's get started. Today, I will introduce the first part, how to use MySQL tenants for regular database development. We will introduce it from the following three aspects: client, driver, and ORM framework. The client includes command line client, graphical interface tools, and connection pool configuration introduction. The second aspect is the driver. It supports multiple programming language driver, just like Java driver, C driver, Python driver, and Go driver. ORM means object relational mapping. It's a virtual object database that can be used in programming language. For example, Spring Boot, Spring Batch, and others. Let's first look at the MySQL connection method. MySQL is the command line client for MySQL database and needs to be installed separately. OceanBase Community Edition only supports MySQL mode tenants. We need to note that make sure that the MySQL client is correctly installed locally. The current version of MotionBase database supports MySQL client version, including version 5.5, 5.6, and 5.7. Make sure the path environment variable contains the directory where the MySQL client command is located. Before connecting to a tenant, please confirm that the current client is the tenant is in the tenant whitelist. Below are the examples how to use MySQL to connect to OceanBase. One is the connection with ODP. The other one is directly connect to OB server. Next is the description of the connection parameters. Here we mainly focus on -u. When using ODP connection, be sure to add the cluster name, OBDemo. If connect to OB server directly, no need to add the cluster name. There are also -c and -a parameters. -c indicates that commands should not be ignored in the MySQL runtime environment. Hint is a special comment and is not affected by -c. -a indicates that the statistics are not automatically obtained when MySQL connects to the database. We recommend the user to add the parameter -a. Next, let's look at the OB client. OB client is a standalone interactive and batch query tool that requires separate installation. It provides a command line interface for connecting to OceanBase database. serving as the client for both MySQL and Oracle tenants. After connecting to the OceanBase database, you can run some database commands, including common MySQL commands, SQL statements, and PL statements through OB client. It's used in almost the same way as MySQL, including connection parameters. Here is an example of connecting using MySQL client. After connecting, execute the show database command for example. We may encounter some common errors when connecting to the OceanBase database. Here are some of them. Now, the first one, business database connection error. And the next is the wrong port. And the next is the cluster name is incorrect. The next is the wrong tenant name. And the next is wrong password. The last one is directly connect to OB server, but fails in the cluster name. Next, we will introduce the graphical tools in the connection method, namely ODC, 𝘠𝘠𝘴𝘵, and 𝘠𝑗𝑗𝑘𝑡. ODC is an enterprise-level database development platform tailored for OceanBase. ODC supports MySQL tenants and MySQL databases connected to the OceanBase, and provides database developer with functions such as daily database development operation, web SQL diagnosis, session management, and data import, export. 𝘠𝘠𝘴𝘵 is a general database client tool that can be used for OceanBase development and debugging, and database management and maintenance, and so on. 𝘠𝑗𝑗𝑘𝑡 is a versatile database client tool designed to connect to database using the GDBC driver provided by each database system. It supports a wide range of database types, including relational, non-relational, and distributed database. To connect to the MySQL tenant of the OceanBase, you can use either the OceanBase specific driver or the built-in MySQL driver in 𝘠𝑗𝑗𝑘𝑡. When using 𝘠𝑗𝑗𝑘𝑡, we need to pay attention that the current OceanBase MySQL mode does not support event. Some versions may prompt event-related errors when connecting to the database, but you can ignore them directly. What we are showing you here is the web interface of ODC. After logging, we can click the Create Database button. Here we can see how to create a new connection to the data source, including the connection address, database account, connection method, and others. It should be noted that as we just mentioned, if you want to connect directly to OB server, then the cluster name does not need to be filled in. Next, we will introduce the data source configuration of the connection pool. The parameters here include ZDAL, DROD, DBCP, 𝘂𝑃H. You can view this part on your own. We will not introduce it in detail. Next, we will briefly introduce an example of GDBC connection pool. Here are some commonly used parameters, such as use local session state, connect timeout, and others. You can check the description of these parameters after this lesson on your own. And let's introduce several language drivers. When connecting to MySQL tenant of OceanBase, the supported drivers are Java, C, Python, and Go driver. When you use it, you can refer to these examples. The link is here. Here is the Java sample program for your reference. You can review it after this lesson. And for ORM framework, we support Spring Boot, Spring Batch, and others. You can check it according to the link of the official website. Next, let's talk about the database objects. Database objects are the components of a database and refer to objects that can be operated and used in database through SQL. The following will introduce the database object types, storage methods, and dependency between database objects supported by OceanBase MySQL mode. The database object in OceanBase MySQL mode mainly include tables, views, indexes, partitions, sequence, triggers, and store procedures. When the database is running, it's often necessary to create different users and grant them corresponding permissions. Generally, users who are granted the create user permission can create users. By default, the business tenants root user is used to create other business users. For detailed information, please refer to the official website. Next, let's look at the username rules. When creating a username, it must be unique within the tenant. However, users in different tenants can have identical usernames without conflicts. Since system tenants and MySQL tenants belong to the same capability mode, it's recommended to use a specific prefix for usernames and system tenants to distinguish them from users and regular tenants. The naming convention for usernames. When creating user use OB client, ODC, and other clients, it's required that the username length does not exceed 64 bytes. And when creating a user in OCP, the username must begin with an English letter and can include uppercases and lowercase letters, numbers, and underscores. It must be between 2 and 64 characters in length. Let's look at an example of creating a user. Currently, two methods are supported for creating user. The first one is directly create user, and the next one is the grant statement automatically create users. You can then use the show grant command to view the user permissions. What we need to pay attention to is OceanBase MySQL tenants do not support updating the password field in user metadata. Let's briefly introduce the database management. Before managing the database, you need to confirm the following. The OceanBase cluster has been deployed and MySQL mode tenant has been created. And next is the MySQL tenant has been connected to the OceanBase. The last one is the create, out, and drop permissions have been obtained. When creating a database, please note the following restrictions. And the first one, in OceanBase database, the name of each database must be globally unique. And next is the database name is limited to 108 and 28 characters. And the third is it can only contain uppercase and lowercase letters, numbers, and underscores, dollar signs, and Chinese characters. The last one, avoid using reserved keywords as database name. For detailed unreserved keywords for OceanBase MySQL mode, please refer this link. Below are some suggestions for creating a database. The first one, it's recommended to give a database a meaningful name that can reflect its purpose and content. The next is, it's recommended to use the root user to create the database and the related users, and only grant necessary permissions to ensure the security and the controllability of the database. The next is, when creating a database, make sure to set the appropriate default character and collation to ensure that the data is stored and sorted correctly. To adapt to the long-term development of the business, it's recommended to use the UTF-8 character to set encoding when creating a database to ensure that most of the characters can be stored. The last one is, you can create a database name with pure numbers by surrounding it with backticks. But it's not recommended because the kind of the database name has no obvious meaning, and the backticks are required for query usage, which will lead to unnecessary complexity and confusion when using it. Next are the examples how to create a database. The syntax is the same as MySQL. It should be noted that when creating a database in OceanBase, you can add attributes to the database, such as read-only and read-write. After creating a database, we can create the table. The OceanBase database supports primary key tables and tables without primary keys. Primary key table is a table with a primary key. The table with the primary key needs to meet the following rules in OceanBase. Each data table has at most one primary key column set, and the number of the primary key columns cannot exceed 64, and the total length of the primary key data cannot exceed 16 KB. For the table without a primary key, we need to note that OceanBase uses a partition level auto incremental column as a hidden primary key. Next, let's look at the restriction and suggestion for creating tables. Below are the restrictions on creating table. The name of a table cannot exceed 64 characters. The row length of a table cannot exceed 1.5 million bytes. The number of the columns in a single table cannot exceed 4,096. And the number of indexes in a single table cannot exceed 108 and 28. The total number of the primary key columns in a single table cannot exceed 64, and the total length of the primary key data cannot exceed 16 KB. The last restriction is the max number of partitions for a single table is controlled by the tenant level configuration item max partition number. And next are the suggestions for creating tables. The first one, it's recommended to consistently use either all uppercase or all lowercase. English letters for table names, avoiding the mixing of upper and lowercase letters. The next one is it's recommended that the table names should be self-explanatory. The next one is system reserves words and keywords should not be used in the table name. And the next is the intermediate table. It's used to return the intermediate result set. The last one is the backup table. It's used to backup and capture the source table snapshot. Next is an example how to create a table. We need to note that OceanBase MySQL tenants supports foreign keys. However, in a distributed database, if the read and write concurrency is high, it's not recommended to use foreign key constraints at the database level. Foreign keys will increase unnecessary blocking and deadlocks, which may hurt performance. Next, let's look at how to copy a table. There are two ways. One is to create a table T1 like while, and the other method is create a table T2 as select star from while. The difference between these two methods is create a table as select statement only copies the basic data types of the table and does not copy the primary key, unit constraint, and the index information. Next, we will introduce the index. OceanBase database adopts a cluster index table module, allowing you to create indexes on specific fields based on your business requirements. This helps accelerate queries on these fields. Before creating an index, you need to confirm the following. 1. The OceanBase cluster has been deployed and the MySQL mode tenant and the user have been created. The next one, the MySQL tenant has been connected to the OceanBase database. And the database and the table has been created. And the last one, the index privilege has been obtained. Creating index has some restrictions. The first one, in OceanBase, index name must be unique within the scope of the table. And the length of the index name cannot exceed 64 bytes. And when using a global index, the partitioning rules of the global index does not necessarily needed to exactly the same or consistent with the partitioning rules of the table. Unique index usage also has some restrictions. The first one, you can create multiple unique indexes in a table, but the column volumes corresponding to each unique index must remain unique. The second one, if you want the combination of other columns in addition to the primary key to meet the global and its global uniqueness requirement, you need to use the global unique index to achieve it. And the last one is when using a local unique index, the index must contain all columns in the partition function of the table. Here are some suggestions when creating index. Feel free to check it out yourself. We only emphasize one point: the suggestion when creating efficient indexes. The index should contain all of the columns required for the query. The more columns it contains, the better. This can minimize the number of the rows returned to the table. And the equal value conditions are always placed first. And the last one, the filtering and sorting large amounts of data are placed first. The following is an example of creating an index. After creating the index, we can use the showIndex command to view the index. For more detailed syntax related to the index management, please check the official website. In addition to the tables and indexes just introduced, we also have some self-programs such as functions, triggers, and store procedures. For details, please refer to the official website. We will not introduce them in detail here. After creating the table, we can insert data into the table. We support both single row and multi-row inserts using the same syntax as MySQL. In addition to using the insert command to insert data, you can also use the replace into command. Please refer to the example next to it. Next, we will introduce the update operation of the data. We need to note that when executing an update statement, be careful not to make the transaction too large. You can use the limit keyword to control the number of the, or the where keyword to control the range. This arises because updating data without conditions can create a large transaction when the number of records reaches hundreds or of thousands or millions, potentially leading to execution fail. In addition to explicit update statement, other statements can also update data. For example, when you inserting data through the insert statement, due to constraint conflicts, you can use the unduplicate key update clause to convert the insert to update statement. Next, we will briefly introduce the delete statement. Here we need to note that we have some suggestion with update statement. When there are more than 1 million records in the table, deleting them all at once may cause performance problems. It's recommended to use the where condition to delete them in batches according to the information in the table, or directly use the truncated table statement to clear the table data. The truncated table statement is used to empty the specified table, but retain the table structure, including the partition information defined in the table. Next, we will briefly introduce the replace into statement. We need to note that the table needs to have insert, update, and delete permissions to use the replace into statement. The replace into statement will judge the replacement data based on the primary key or the unique key of the table. If there is no primary key or unique key conflicts, then insert the record. If there is a primary key or unique key conflict, delete the existing record first, and then insert the new record. It's recommended that the target table has a primary key or unique index. Otherwise, it's easy to insert duplicated records. There is an example of replacing to the right side. On the right side, In this example, we use replace into statement to insert data. You can see the following two examples for yourself. We will not introduce detailed information about the two examples. Next is the first example. When there are data records in the table and the inserted data has a primary key or unique key conflict, the replace into statement can be used to delete the conflicting data in the table and replace it with the new data. Okay, we will introduce the query operation. The query syntax of OceanBase is basically the same as that of MySQL. The explanation of parameters is basically the same as that of MySQL. Here are some common parameters and descriptions. Feel free to review it on your own. When we usually do query operation, we often use query conditions to filter. To query data that meets certain conditions, you can add a where clause to the select query statement to filter data. The where clause can contain one or more conditions, which are used to filter data, and the data that meets the where conditions will be returned. Here we list the common query conditions type. For more information about the comparison operators, please refer to the official website. You can use the group by clause to group query results in SQL queries. Group by supports single field grouping and multi-field grouping. Before grouping, you can use the where clause to filter data, the having clause to filter data after grouping, and the order by clause to sort data after grouping. When using the group by clause, the columns in the select statement must be columns or aggregate functions in the group by clause. When using the having clause, the having condition filters the group result instead of the original data. When the query contains having, the SQL query result without having clause is obtained first, and then the having condition is used to filter out the matching data based on the result. And finally, the data is returned. Therefore, the aggregate function can be used after having, and this aggregate function does not have to be the same as the aggregate function after select. Next, let's look at an example of adding the limit clause to a query statement. In the SQL queries, you can use the limit clause to limit the number of rows returned in the result set. Limit clause can also be used in pagination queries. Let's see the example on the right side. In the student table, there are 4 rows of data in total. 2 data are displayed per page. Get the data of page 1 and page 2 in turn. Let's briefly introduce the subqueries. A subquery is a query nested within a parent or outer query. The subquery's result is passed to the parent query as input, which then incorporates this value into its calculation to produce the final output. 𝘂𝑃L allows multiple nested queries. That is, a subquery can be nested in other subqueries. For detailed syntax related to subqueries, please refer to OceanBase official website. Next, we will introduce a very important concept in database. It's transaction. A database transaction contains a series of operations on the database. A transaction transforms the database from one consistent state to another consistent state. Database transactions have two functions. The first one provides a method for database operation sequences to recover from fields to a normal state, and also provides a method for database to maintain consistency even in abnormal states. The next is provides isolation for multiple concurrent accesses to the database to prevent multiple concurrent operations from causing the database to enter an inconsistent state. In OceanBase, we have some basic statements to control transactions, such as begin, save point, commit, and rollback. There is a parameters we need to pay attention to. It's auto commit. You can control whether the transaction is automatically committed by modifying the session level auto commit variable. If the auto commit value of the current session is 0, and there is no explicit transaction commit, when the program is abnormal interrupted, the OceanBase database will automatically roll back the last uncommitted transaction. Next is an example how to control a transaction. We need to pay attention that after configuring auto commit is 0, it means turn off the auto commit. The system will open a new transaction by default when executing insert, update, delete, or select for update statement. When a transaction is started, the OceanBase database assigns it a transaction ID, which uniquely identifies the transaction. When operating on the same table and multiple concurrent connections, two transactions may operate on the same row of data. For query operations, you can use the select for update statement to log the query results to prevent other DML statements from modifying the result at the same time. We can also use the statement to check the status of the transaction. Save point. Save point is an execution marker within a transaction that can be defined by the user and provided by the OceanBase database. Users can define several markers within a transaction and restore the transaction to the state at the specified marker when needed. When the user performs some incorrect operations after defining a save point during the execution process, the user doesn't need to roll back the entire transaction and execute it again, but can roll back the changes after the save point by executing the rollback to command. As shown in the table, user can create save point SP1 to roll back the data inserted later. In the implementation of OceanBase, each modification during the transaction execution has a corresponding SQL sequence, which is incremented during the transaction execution. The operation of creating a sale point maps the sale point name created by the user to the current SQL sequence of the transaction execution. When the 𝘤𝑏𝑎ck2 command is executed, the following operations are performed inside the OceanBase database. The first one, rollback all modifications in the transaction that are greater than the SQL sequence corresponding to the sale point, and release the corresponding row logs, such as row 2 in the last example. And the second one, delete all sale points created after the sale point, such as SP2 in the last example. And after the 𝘤𝑏𝑎ck2 command is executed successfully, the transaction can continue to operate. For detailed information, please refer to the official website. And let's go back to the last example, and I have a question for you. After the transaction is committed, do you know which data is successfully inserted into the table? You can put your answer in our QA channel. And it's a very simple question, right? I believe you know the answer. Yeah, it's very simple. Okay, next let's talk about the commit transaction. The database can commit transactions explicitly and or implicitly. To commit a transaction explicitly, you need to use the commit statement to end the transaction. Implicit committed doesn't require active commit. When the variable auto commit is set to 1, after each statement is executed, the OceanBase database will automatically commit the transaction. So one statement is one transaction. The OceanBase database will implicitly initiate a commit statement before and after the DDL statement, and will also commit the transaction. Implicit commit refers to the process where the OceanBase database automatically executes a commit for the current active transaction, without requiring the user to explicitly issue a commit or rollback statement to end it. Implicit commit happens when execute a statement that open a transaction or execute a DDL statement. Here is an example showing us how to commit a transaction explicitly. Start a transaction with begin, and then use the insert statement to insert data into the table. And finally, commit the transaction explicitly with the commit statement. You can see that we called the commit command explicitly. Next is an example showing us how to commit a transaction implicitly. Here we need to set the auto commit to 1. You can check this example on your own, and we will not introduce it here. Next, let's introduce the rollback transaction. Rollback transaction means undoing all changes made to the transaction. You can roll back the entire uncommitted transaction or roll back to any sale point in the transaction. After rolling back the entire transaction, all modifications are discarded, and all sale points are cleared, and all logs held by the transaction are released. Next, let's look at an example. A transaction is explicitly started using begin before the transaction is explicitly committed, or changes are visible only to the current session and are not persistent. You can use the rollback statement to roll back the changes. Next, let's talk about the other scenario of rollback. It's automatic rollback. Automatic rollback is a rollback initiated by the OceanBase database without the user issuing a rollback command. It usually occurs in the following situations. The first one, session disconnected, and transaction execution timeout. And the last one, the session of the active transaction has no statement executed for a certain time. At last, there is an exception scenario. The transaction is interrupted. When an internal error occurs during the execution of a transaction, such as a node crash or other reasons that cause the transaction to be unable to continue, the current transaction cannot continue to successfully execute statements and can only be rolled back. When this happens, the user will receive a transaction need rollback error when executing SQL statement, and the user needs to execute the rollback command to end the current transaction. And let's introduce the isolation level. As we know, the transaction must comply with ACID. And in ACID, I means isolation. Isolation level are used to describe the degree to which transactions interfere with each other when they are executed concurrently. The SQL standard defines 4 isolation levels based on the abnormal situations that must be avoided during transaction execution. The higher the isolation level, the less mutual influence between transactions, and the fewer abnormal situations are allowed. These abnormal situations that need to be avoided include dirty read, non-repeatable read, and phantom read. Dirty read is a transaction read data that has not been committed by other transactions. Non-repeatable read is previously read row of data is found to be modified or deleted upon subsequent query. A phantom read is during an execution request. If the same search condition is executed again, the result set may include a row that meets the condition and was newly inserted by another committed transaction. Different isolation level has different abnormal situations. From the left table, we can see the detailed information. The isolation level includes read uncommitted, read committed, repeatable read, and serializable. OceanBase in MySQL mode supports read committed, repeatable read, and serializable 3 isolation level. The default isolation level of OceanBase is read committed. Next, we can see the comparison between OceanBase and other common databases in terms of isolation level. Feel free to check it out yourself. At last, let's introduce the specific difference between OceanBase MySQL mode and the MySQL database transaction isolation level are as follows. The first one, read uncommitted. The MySQL database supports read uncommitted, but OceanBase does not support read uncommitted. we do not support read uncommitted. The second one, read committed. In MySQL, semi-consistent reads determine whether a row needs the update condition under the read committed isolation level. If a concurrent transaction updates the row, MySQL waits for the transaction to complete before evaluating the latest version. While in OceanBase, the evaluation always relies on the version in the statement's snapshot, regardless of any concurrent updates. And the third one, repeatable read. In the repeatable read isolation level, MySQL handles read conflicts by making the later transaction wait for earlier transaction to complete. If the earlier transaction is rolled back, the later transaction updates the original version. If the earlier transaction is committed, the later transaction updates the newly committed version. While in OceanBase, the later transaction also waits for the earlier transaction to finish. However, if the earlier transaction is rolled back, the later transaction updates the original version. If the earlier transaction is committed, the later transaction is rolled back and returns an error. The last one is serializability. MySQL's serializability isolation uses two-phase locking, which can ensure strict serializability. However, OceanBase's serializability isolation uses a snapshot isolation, which cannot guarantee strict serializability. Okay, if you have any question, now is the perfect time to ask. Okay, it seems no questions for you. Good. Before we wrap up, I'd like to remind you that our next lesson will be on next Thursday evening, where we will be covering the remaining part of this topic. We look forward to seeing you then. You can also reach out anytime through our OceanBase GitHub or Slack community for further assistance. We are always here to help. We will be sharing how you can access all materials on the today's presentation slides in the comments section of this video. All the resources are free. Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye-bye.